Hello, my name is Victor Lopez, and today I'm going to work a little bit on Python.cards. Given this is the first video I do about this project, let me first introduce the project. Python.cards is a service, it's a tool to learn Python via spaced repetition. If you don't know what spaced repetition is, it is a method of learning that tries to be kind of optimal in regards of the time you spend. So given this demo here, what happens is that you every day you log in onto Python.cards, or you would get an email in our case where it says, hey, you have this many cards to review. You click that link and then you get sent to one site similar to let me find it. So this one here, right? So it says daily study, 0 new cards, 3 cards to review. And here you will get some question, you think about it, and then show the answer. And whatever the answer you find, you would choose if it's easy, hard, good, or you need to see it again. So you would go through all of your cards, good, easy, and so on. So this is an optimal way of every day learning a little bit. Every day you review your cards, and then your knowledge starts to grow. And luckily, because of how memory works, you don't need to study that much. You just need to get reminded at the right intervals of the right questions. If there's one flashcard you forget, then you go back to it more often. And that way, the cards that are harder for you to learn, you see them more often, and the ones that are very easy and you already remember or you learn them very quickly, you start to review them at longer intervals. Think that if there are some card that is very easy for you, you might get it so after 3 or 4 easy times you click easy, then you might see it like 1 year from now. So, and in fact, you remember it. So I did a simple test with the, what's it called? This alphabet, the Alpha, Bravo, Charlie, Delta, and so on. I had no clue about how this alphabet, what these words were for this alphabet. And honestly, after reviewing it, like in my lifetime, I have spent less than 30 minutes knowing this alphabet, but I learned it more than 1 year ago, and I just remember everything. And every few months, it comes to my mind, and I remember like the whole alphabet. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, and so on, right? So even the most absurd or let's say arbitrary facts you can learn, in case of this alphabet, which you don't have anything to connect it to. Well, you know that the letters in the alphabet, that's the only thing you know. But in the case of Python, which is a huge programming language that has many libraries, that has a big standard library, and has many features, information is connected. So once you start to learn more and more, not only about the syntax, about the culture, about the history, about why things are done one way, about what are the right ways to do things, and so on, all of this knowledge starts to pile, and you start to be more productive, to understand more the concepts, and so on. So this is the idea behind Python.cards. I have some decks that I'm starting to build. It's easy, it's fun, it works, and it is launching soon. So stay tuned, say your address. Probably I might launch it in a few weeks, just when we have some cards. Okay, so we have this introduction. What is Python.cards? What do I want to do today? So today I want to create some cards. So the site is built, the tool is built, it sends the email address, it has the spaced repetition algorithm implemented, and so on. The only thing that's missing are some cards, right? So I will record a video today. So this video you're watching will be about creating some cards, but every few days I will record some videos. This is just a way for me to get some attention, right? I have 0 followers, but I think this is very interesting. And also it is a way for people to see like what's in these cards. So one thing that happens very often with these cards, if you allow me this detour, is that so the popular project for spaced repetition is Anki, right? And the problem with Anki is that it is very it is kind of not very user friendly, let's say. It is user-friendly, but the whole process of creating the cards is a bit cumbersome, and you can tweak every parameter of the algorithm and so on. So what happens with this kind of thing? So there are two sides. So on one side you have like Duolingo and all of these language apps that do space repetition, but it's a very clear path what you need to do. And then there's this Anki where you can change everything, and there's people learning languages but also learning programming or learning any other thing. The problem with Anki is that you need to spend a lot of time creating your decks. It doesn't come with decks of cards that you can learn from. And with Python, but however, and you could think, and I also thought, or I had this idea maybe, that it's not that space repetition works. It works because you are the one creating the decks. And I agree that the decks are the most important thing. So if you want to learn something, the deck must be good, but it's not necessary for you to create it. So in this video, I will show you how we create one deck. I will create more and add more cards in the future and so on. So you can watch the video. It will be many hours probably of work creating all the decks, but then you can build upon all of this work and just log in or join Python.cards and learn from the cards directly. No need to go through the pain of creating all these decks. So anyway, that's enough of an introduction. Let's get started. So I had here said that I would start with the nomenclature, the built-ins, the tour of the standard library, but today I will start with something different, okay? There's like this, I will start with something niche, and I will also add some cards maybe to nomenclature or culture or history and so on. So today we're going to start with the pathlib, okay? Python pathlib. What is pathlib? In Python 3.4, this library appeared, and this is the, let's call it the right way of managing paths, right? So before, let's open the Python interpreter. Before, you would do from OS import path, right? And path, I don't know, file.txt, and I guess you could do, no, it's not callable. I don't even remember. Yeah, it's os path join. This is the classic thing. So you would say directory file.txt. So you had all of these kind of functions that would join this, and this is portable, right? This would work both for Linux and for Windows. So this is what we had in the past, and if you check the os path docs, it has a lot of functions, so the ops path and so on. This was kind of like the old way of managing paths. But then on Python 3.4, the pathlib library was created. And what is this library? Excuse me. So this library is like the right way of managing paths. So from pathlib, import path. And here you would create this path of file.txt. And then it has this nice, so let's call this filing, right? Or file or F or whatever, F. So now you have F, this is a POSIX path. So here you could do F/ or home join F, and you can do that. But if you put a slash here, it gives you the same output, because this is not just joining two paths. Joining two strings. This is joining two paths, so it knows that is redundant, right? So even if you, I don't know what happened if you do that. Okay, and support the F string and string. Oh, because it's doing the string first, right? If you, it's very stupid what I'm trying to do. I understand, but you could do this like this, right? So this would work because it would do this first, which is a string and a file and a string and a file. So sorry, a path. So anyway, what I'm going to do is I'm going to create these cards in Markdown, and then I'm going to write some import script to import it into the database for the Python.cards site, right? For now, I will just do everything in Markdown because it's very convenient. And then maybe today, maybe some other day, I will create the code to translate it to the app. Okay, so I mentioned this before. So what do we want with the cards? We want them to be atomic. We want them to have, we want to cover like everything. This will be kind of, let's call this deck, pathlib in depth, we could call it. I don't know if we want to make it lowercase or code or something like that. Okay, so pathlib in depth. So I'm basically going to create some cards. So for example, pathlib when, and the question, when was the pathlib module introduced? Okay, so that's one question. And then the answer would be in Python 3.4. Or we could write them more. Well, let's keep it very, very, very short. In Python 3.4, which was, I think, 2014. Yeah. The year 2014. So this is one card, right? When you would see this question, when was pathlib the model introduced or added to Python, to the Python standard library, and that's when it was. Okay, so more stuff. We could say pathlib pep. So which pep, and if you know pep, this is a Python enhancement proposal, right? The Python enhancement proposals. So which pep introduced the pathlib? Okay, and here we could add some tags. So this could be history. Okay, I think this is kind of history, and this is kind of, or let's call it culture. Culture, and then we can filter. This is Obsidian, by the way. I'm using Obsidian. I'm not a huge user of Obsidian, but this might be helpful. So then we can filter all the culture cards and so on. Okay, so which pep introduced the pathlib? And this is, again, is culture 2, right? So which pep? Maybe we want to remove the spaces. No, maybe we don't want to remove the spaces. Otherwise, it's a heading. So a header. So it was introduced in pep 4.2.8, and that's it. Okay. Culture. Next thing. So now we could go through the API, or we could go through many things. This class diagram is interesting too, but we might want to, I don't know where to start. I think we can cover this later. By the way, I'm going to create all these cards like in whatever order they come, but then I will try to find an order where it makes sense to learn them. So you don't want to get like all the culture questions first. You don't want to do that. You want to have like probably the most interesting things first, or the most important things first, or something like that. And then this kind of culture questions, so you might want to have them split around the whole deck. So okay, let's start with let's start from somewhere, the operators. Well, the operators are interesting. So here you have what's called the slash operator. And that is something nomenclature which I like. So let's call this slash operator, or we could call it pathlib slash operator. Okay, so here I'm going to have a new label which will be nomenclature. And how is the slash operator called? For example, so here this is some Python code, and we will have from pathlib import path, path directory slash file.txt, something like that, right? So let's put this kind of exclamation marks around this, and we'll try to make this code around the exclamation marks to be inside a rectangle or something like that in the front end. Okay, so we will keep that. If you check this thing I have here, well, maybe in the Python.cards, here this thing I created this. This is kind of an SVG that is on top of the code, the actual code, and it then disappears. And that's so we can do something similar, but to create a rectangle. Okay, so how is this operator called? For example, in blah blah blah, it's called the slash operator. Okay, so it's interesting to have like this, to say the things by their name. So this helps join. It allows you to join paths, something like that. Okay, so we have the slash operator, which is one of the important things of pathlib. Okay, so now what else can we see from here? We have these pure paths and pure Windows paths and so on. This is related to this class diagram. We're going to come back to this thing, but not yet. Okay, it's also interesting to read the PEP. So here in the PEP we will find some stuff that we might want also to use. Okay, so basic use, pure paths, operators. We already saw the slash operator. A path object can be used anywhere an object implementing is accepted. Okay, the string representation of a path is the raw file system path itself. Calling bytes on a path gives the raw file system path as a bytes object encoded by OSFS encode. Okay, not so interesting, but this is more interesting. Because here what happens, imagine you create a path like this. Home file.txt or home Victor file.txt, right? And let's call this P. So P is this path. So for example, the parts, this is what we're doing here. It's separating all of this stuff. But you might think that it's called, parts, which is not. So let's start with this, adding some questions for all of these methods, properties, and so on. So the question here would be, how can you access the different components of a path? Different components of a path. And here we can add this snippet, right? So we will do from pathlib, import path, P equals path, or let's say file name, or let's call it path equals path. So home user file.txt. and then you would print this, right? Print, and now you print p.parts, and you get this output, which is, and I'm going to add this kind of thing, and then you get this output. And careful, because this is the user, right? So this is the kind of thing that we want to say, but here I'm going to block, and I do that with this character, tilde character. We're going to hide this text. So now the user will have a card where it shows, let me show you how this works. Okay, so let's go to the admin database, cards, add card. Let's say p dot, well, you don't even need a back. Okay, let's put this here. And this is pathlib parts. Okay, save and add another. Okay, so if we now go to cards, okay, we see this thing here. This is not hidden. Why is it not hidden? Why is it not hidden? Probably because I'm not writing the right thing. So how can I show you this thing? You could come here to the code. Let's check the demo. Demo session. What is the demo session? Demo session cards, views, demo session. Don't know what's the easy way of creating this. Let's see. Let's go to the admin. Sessions. I'm going to delete all sessions. Okay. And now let's create a session. Or create all sessions, right? So I get this email where it says that you need to visit this website here. And now let's go to this site here. One new card. Okay, here's the card. And here you can see what I was trying to show you, right? So how can you access the different components of a path? So from pathlib, you import path. You have this path, which has this name, and then this is blocked. So here you have this. You have to think, okay, what's the way of calling this? And the answer is parts, right? So here you would say p.parts. So this is how this tilde thing is working. One day I can show you how that is implemented, which is interesting. So the answer basically is, and we could add an answer here. It would be, let's see if we can put this together. Yeah. P dot, or sorry, with one P dot parts. I don't know if we want to put it into the, do we really want to have it in this way? I'm not sure. Show answer P dot parts. Okay. So that's the idea. So let's continue. So with the parts, you're able to get the different components of a path, which is obviously useful. So then methods and properties. The drive. What is the drive in a POSIX path, and what's the drive on a Windows path? If any. So this is a kind of like a Windows specific thing, right? The drive. So pathlib drive. So here you would say, how do you access how do you get the drive letter or name of a given path, right? So you would do, and then you have this thing here. So this introduces the concept of all this, the pure Python, pure Windows, pure POSIX, which is interesting. Okay, so here, and you would say with P, or let's say pure path dot drive. Here we could edit this thing here to also say the same things from pure path dot paths. The interesting thing about the pure path is that so this is because of this class diagram, right? So every path is a pure path, right? So, but not every pure path is a path. So the thing with pure paths is that they allow you to modify paths regardless of the actual operating system that you're working on, right? We are going to write some cards about this later. Okay, so they are pure paths and concrete paths. That's also an interesting nomenclature thing. Let's write it now. And then we'll get back to the properties and the attributes and so on. So let's add it around here. So pathlib pure versus concrete. Okay. The pathlib library contains classes for two kinds of, it's not only two kinds of paths, for two main the pathlib library divides paths into two groups. Which are those? You could argue it also divides into two, the pure POSIX and the pure Windows, but it's not only these two, because there's also the ones that include both, right? So which are those? And now this one is interesting. This one is interesting because you need to now it's important what's the next question for this one. So let's call it pure paths and concrete paths. So now the question is, what are these, right? So these modules of class representing which provide purely computational operation without input-output, and concrete paths which generate from pure paths but also provide input-output operations. If you've never used this module before or just aren't sure, path is the most likely what you need. Yeah. If you want to manipulate Windows on a Unix machine or vice versa, you cannot instantiate this when running on Unix. So let's say pathlib pure. So the question is, what are pathlib pure paths. So pure paths provide, you could copy this thing, right? Allow you to manipulate paths without any input output operation. They are useful if you want to manipulate Windows paths on a Unix machine and or vice versa. So allow you to manipulate paths. Yeah, that's it. They are also useful if you want to make sure that your code manipulates paths without actually accessing the OS. Okay, so there are two things. So what are pathlib pure paths? Should we create this? We could even create this separate pathlib pure useful. What are the two main reasons in which two main scenarios are pure paths useful? Okay. They are useful if you want to manipulate stuff or to make sure to manipulate Windows paths on a Unix machine or vice versa. Okay, because we didn't say this, but you cannot have concrete paths. Let's put it in a different way. So pathlib concrete path OS. So the question is, can you instantiate a Windows path? Let's try it. Let's try it, right? From pathlib import Windows path, not implemented error. So instead of saying, let's add this exception, right? What happens if you try to import a Windows path on a Unix based machine? And this is what happens, right? So we say from pathlib import Windows path, Windows path. And then you get this error, right? Trace back. Let's try to, I don't want to kind of write all of this. Okay, Python versions, whatever, race not implemented, blah, blah, blah. So you get all of this. And we want to hide this, right? Trace back. I don't know if this thing works if I put it in this way. Like all of the, like a multi-line. I don't remember if I implemented this. So let's see it, what happens. Save and continue editing. Refresh this stuff. No, it doesn't work. I think you need to, what happens if I do it here? Save and continue editing. What's the problem? What did I do? I did it here, but I didn't edit it here. Save and continue editing. Okay, now I block this stuff, right? So raise not implemented error. Okay, so here we could have some. Could we kind of like add these spaces so we don't know what's happening here? Let's see how this looks like. Save and continue editing. Yeah, so we see this stuff here. Oh, the Python thing. Save and continue editing. Okay, this will look cool. So okay, what happens? How can you access the? Well, no, that's so trace back not implemented error, right? So even if I used user being Python 3, want to get which one is this? 3.8. Okay, yeah, let's try to use this. I will get this error. So I like this error better, right? So the thing is I will get this error from 3.8 in this case. Doesn't matter exactly the version. Okay. So this is another thing that I want to push through Python.cards, which is the handlings of exceptions, right? I think it's useful to have a sense of what exceptions you get. So when you get a not implemented error or a division by zero, this kind of thing, if you know your exceptions, you can jump faster to the conclusion of what the problem was and so on. Okay, so what happens if you try to import Windows Path on a Windows machine? It doesn't work. It raises a not implemented error exception. You can only, well, okay, so that's what happens, right? So what happens if you try to import a Windows Path on a Windows machine? It doesn't work. It raises a not implemented error. The same thing happens if you try to use POSIX path on a Windows machine. Okay, so let's say concrete path wrong OS, right? That could be a good name for this stuff. So we have this thing here. Then why are the pure paths useful? That's interesting. We might want to move this thing around. So, and then the pure, what are pathlib pure paths? Allow you to manipulate parts without any input-output operation. We still need to add more things, right? So we have pure versus concrete. Okay, so this is the rabbit hole, but we're going to we're going deep into it. So in the PEP we have this thing, right? So we can so let's say pathlib class hierarchy 1, because I think we're going to have more than one. So here, let's say pure path is hidden, okay? And let's copy this stuff. Let's see if this works, or we are only, I'm not sure if we are only, modifying this stuff through, for the Python cards, snippets. No, this works. Okay, so we have this snippet here, and we want to know which class is in the top of this diagram, right? We could have so we have this diagram with arrows, and this is kind of like an ASCII art, but we could live with this, right? So here we would say what is the class that is hidden, right? So what is the class that is hidden? Pure path. Sorry, just pure path. Okay, so, and then we could copy this kind of card and have to, what is the class that is hidden? Pure POSIX path. They're the classes that are hidden. So we have pure POSIX path, pure POSIX path, and POSIX path. So, I mean, we'll have to see in practice if this makes sense or not. Pure Windows path and Windows path. And then finally, we're going to have the path. What are, and then what is the class that is hidden? And now we're going to hide the path one, which is the one that you will usually use most of the time, right? The path, but not always. This is, remember, this is pathlib in depth, so we need to go in depth. And honestly, it's not that hard. It's not that hard. With Python.cards, you will learn it in no time. Okay, so okay, we have this class hierarchy. We have more or less explained what pure paths and concrete paths are for. It doesn't work. here. You cannot use concrete paths in the wrong for the wrong OS. For the wrong OS, yeah, the wrong or the different OS or whatever. Okay, so we started from the beginning again. We have the pure path, the POSIX path, and so on. Then we know what are concrete versus pure, what the pure is, why the pure is useful, what happens if you try to use a concrete. And then we started with the slash operator, the paths, and the drive. Okay, so let's continue through our list. So we have the parts, the drive. Let's check the root, right? So what happens if you try to get the root of something that doesn't have a root? That's interesting. So what's if you say file.txt from pathlib import path root? Okay, it's empty. Okay, that's interesting. Pathlib root. How do you get the root of a path? And here you would say from pathlib import path, then you create this path. So here the path, again, this is this thing, right, that we are doing here. So this is the what's the root of this stuff is // I don't know Windows. I definitely don't know Windows. So UNC shares always have a root. If the path starts with more than 2 successive slashes, it collapses them. More than 2. This behavior conforms to the Open Group Database Specifications issue 6. A path name that begins with 2 successive there's an implementation defined manner, although more than there's a single slash. Okay, that's a weird thing. That's a weird thing. I don't know. I don't know how deep. How deep are we going into pathlib? Do we want to have all of these details or not? Man. So if we have this path, I mean, we could use the pure path, right? Which is like the what happens if you say pure path of C? Okay. So how do you get the root of a path? Well, anchor, they can containation and drive and root. In the case of Windows or Linux, which is what I'm used to, this doesn't matter at all, right? So, man, I'll put this example. Although I'm not happy with this thing, pure Windows path, pure POSIX path. So we have this thing, and we have this thing, and then we are going to hide this stuff here. So we are going to have with pure path dot root. Okay. this one, we could make it, we could add more stuff, I admit, but we'll leave it for another day. So pathlib anchor. How do you get the concatenation of the drive and root? And this is something that I had never heard about also because I'm probably not used to. From pathlib import pure Windows path, and then we do this thing here. Dot anchor, and you get this thing here. Let's copy everything. I don't think these cards are ideal, honestly, because there's too many. They're not atomic. I mean, there's a single question, but you don't learn like the details of all of these things, what they mean, right? So here you do it with your path.anchor. But let's leave it as a best effort, and then we can come back to this thing later. So now going to more useful things. Okay, so parents is more useful. Parents is more useful. So parents is this thing so if we get a path of home, again, user file.txt, parents, list of parents. Okay, it gets different paths. So it gets different paths. An immutable sequence providing access to the logical ancestors of the path. So here you would say pathlib parents. How can you get a list of all the ancestors of a path, right? So this one is useful, and this one is interesting also, I think, because of the permissions and so on. So that one is interesting. So again, from how far are we? Pathlib import POSIX pure path. I prefer the POSIX the pure POSIX path. So we use the pure POSIX path /home/user/file.txt. So here, what is the POSIX path.parents? It's an immutable sequence. Okay, it supports slashes and negative index values. Okay, so that's before it didn't support this thing. So now you can say, I guess, parents -1, right? Oh, index error. Yeah, because we are not on Python 3.10, right? If I pyenv local 3.11, path, now I get -1. Wait, what is -1? Yeah, the last one. Yeah, that's because I'm in 3.11. So that's interesting too. So let's have a for loop, right? So we can say for parent in p.parents print parent, and then you get this. So for parent in path, let's call this thing p equals this thing here, for d in parents in p dot parents print d. Okay, home slash user. So for d, for directory, let's call it for d. And then you have home slash user, home slash. So we hide this thing here, right? Using pure path dot parents. And you could comment this that slashes and negative index values. So since Python 3.10, you can also parents, so the parents sequence supports slices and negative index values. This is interesting because this is not, as happens many times with Python, this is not a list. This is actually, well, you know, this I don't know even what this is. It's a POSIX path parents. It's like its own class. So it didn't support all of the list stuff out of the box, right? So now pathlib parent. So what about the parent? One parent only. So the logical parent of the path. You can go past an anchor or empty path. So what happens if you try to do the parent of a single file? So what is the parent? Hello? It's the current directory, which is interesting. That's interesting. That we'll have to create a card for. And what about what is this? Okay, that's interesting. So I think for parent we're going to have also different. How do you find the logical parent of a path? From pathlib import pure path. Again, we're all using pure paths because this is all. And let's see how many more things we need to get. Oh my god. We're going to have to add many more cards still. So how do you find the logical parent of a path? So here you have the pure path. I think we can get rid of all of this. So pure path, home user file.txt dot parent home user, something like that. From pathlib import pure path. Okay, pure POSIX path, this thing. Pure POSIX path. Okay. So we have the parent. Using your path dot. Okay, so now you have this, which is cool. But now parent. So what is the parent of a single file? So what is the parent of, and it is the dot, I think. Pure POSIX path dot. Pathlib parent 3. What is we could say pathlib parent single file, pathlib parent root. So we should comment this thing of the root. So what is the parent of this guy? Here, I think it is the root. Am I right? Yes. No, wait. What did I do here? It's the root. So we have the parent of the root. Then this is a purely lexical operation, hence the following behavior. So the parent of this guy, if you want to walk an arbitrary file system path upwards, it is recommended to first call path.resolve as to resolve symlinks and eliminate components. Okay, that is very important. So that's kind of important, right? So pathlib parent only lexical. What is the parent of this directory? So it is of foo slash dot dot. It is foo. So it is foo. The reason is that parent performs a purely lexical operation. It doesn't actually use the real paths on disk, on the file system. File system. In order to resolve symlinks and eliminate components, it is recommended to call path.resolve first. So we will get back to this resolve guy later. So we have the parent of the root, the parent of which is only lexical. Let's get the name. Pathlib name. How do you get the file name, the name of a file? So the name of this guy how do you get the name of, what if you, okay, how do you get the name of so home user file.txt. Okay. A string representing the final path component, excluding the... How do you get the final path component of a path? So for example, pure POSIX path of home user file.txt dot name file.txt, right? And of user pathlib. So you would do it using pure path.name. Question is, what is the name of a root, right? What is the name of a root? Do we want to have a separate card for this kind of edge case? We could have. So pathlib name root. So the question is, what is the name of a root path? So we could say root, or we could say, or a UNC drive. What is a UNC drive? What is a UNC drive? Universal naming convention path. Okay. Okay. So now we know what UNC means. Let's add a card for this, right? Let's add a card for this. So what UNC Windows UNC. What does UNC mean when regarding paths in Windows, right? Well, what's UNC is the universal naming convention. What is the universal naming convention? Which are used to access network resources, which are used UNC paths are used to access and have this format. UNC is this thing here. So a server host name. So basically the UNC stuff. We had some. We saw some things here about UNC. Okay. So which have a format such as this thing here. Such as this thing here. Okay, so we now know what UNC means. So here, let's go back to these guys here. Methods and properties. We were on the parent, the name of a root, right? So what is the name of a root path? Not the root, the name of a root path. Let's have both things, right? So okay, it is empty. And this one is empty too. Pure POSIX path of root is empty. But we'll add some spaces here so we get some like nice box that doesn't hint that this is just an empty string. So both on Windows and Unix and POSIX operating systems, name is empty. Okay, so more things. How many cards do we have so far? Let's check this out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, we're picking up some speed. So now, pathlib suffix. How do you get the suffix of a file? So this is Python. You have a pure POSIX path of my library setup.py. Why not use the same example, right? Dot suffix. We don't want to say the suffix. The file extension of the final component of the path with suffix. So here it is .py. Okay, so that is using the pure path dot suffix, using pure path dot suffix. Okay, but now you can say, okay, suffix of multiple extensions, right? Or suffix multiple extensions, yeah. What is the suffix of this file path? So library.tar.gz. Okay, and it is .gz. Let's try to make this harder, right? So if we say tar.gz, 1, 2, 3, 4. 1, 2, 3, 4. We're going to hide it. So you think it's tar.gz and it's gz in fact. Let's make it a bit longer even. So it is like this. It's .gz. It's not tar.gz, right? It only picks up. So let's say suffix only picks up the last chunk of the name. Divided by dot. Okay, so now pathlib suffix no suffix. So what is the suffix of this file path? My slash file. Sorry, the suffix should be shown. It is empty. It is the empty. It is empty. So that's what it is. If there is no, oh, what about your Python? So what about from pathlib import your path of dot env dot suffix? Okay, it's nothing. But if there's a space, yeah, it works. That's interesting. That's interesting. So pathlib suffix no suffix. So what is the suffix of this file path? It's empty. If there is no dot, the suffix is empty. Okay, so now pathlib suffix hidden file, let's say. What is the, let's copy this again. What is the suffix of this file path? .env. It's empty. If there is nothing before the dot, the suffix is empty. Okay. How so pathlib suffixes. How can you find the list of path of file extensions? How can you find the list of a path's file extensions? So here again, you would do this. Pure POSIX path, whatever, downloads slash file.tar.gz dot suffixes, that's what we're looking for, and then what do you get? So you get this thing here, from pathlib import, never do this at home. You get a list. Actually, you get a list, which is interesting. Because you don't get a list. You don't get a list when you are on with the parents. So that's interesting. Using your path dot suffixes. So another thing, we are still working on the pure path. So the pure path is huge. And then you have all this home, stat glob group is dir is file. So let's check, let's add something here. Pathlib pure versus concrete examples. Given the following two samples of attributes and methods, which belong to pure paths and which to concrete paths. Okay, so which ones? So we're going to have two lists, right? So the lists are, well, the things we're getting, right? So we are going to have parent, suffixes, drive, name, etc. And then we're going to have exists, is there, right? This kind of things. Is there, is file, etc. The first list so of course this is so every path implements also the functions of a pure path. So the first list, the second list is only available for concrete paths, while the first one is only available for concrete paths, while the first one is defined, is implemented on pure paths too. Remember that concrete paths being a subclass of pure paths means that all pure paths attributes and methods are also available for concrete paths. Okay, so the second list is available for concrete paths, while the first one is implemented on pure paths too. Okay, so we have the suffix, multiple extensions, no suffix, hidden files. Okay, using pure path suffixes. And this is a list. It is interesting that the parents is not a list. I don't know if the PEP says anything about that. Parents. An immutable sequence. Immutable sequence of the path's logical ancestors. Why? What is a Python immutable sequence? Why do we want it? Mutable sequence, well, mutable sequences are tuples and strings and so on. Why is pathlib parents an immutable sequence? No, really, Python pathlib is great. It is great. Okay, so where we were. So we were here around the paths, suffix, suffixes, stem. Okay, so pathlib stem. And now that I hear steam, I'm running I'm running out of steam. So we'll wrap this up pretty soon. So how do you get the final path component of without its suffix? Well, the thing is you pure POSIX path my life. Let's copy this example, right? But so this one, my library.tz, is so you get the stem of library.tar, you get this, and of library you get this. So the answer is using pure path dot stem. So we got all the attributes in. But now we need to add some methods. So join path. Relative to, which is interesting, walk up. So that's interesting, with name. So we still need some work to do. Let's add the to do here, right? To do continue with as POSIX and all the other pure path methods. Then what we will have pending are the concrete paths, right? And for the concrete paths, we have this home, glob, is FIFO, walk, which is interesting, lstat, like all this stat stuff also, so to check the file size and so on. Rename, read link. So we still have some stuff to work on. And also here, well, there's this list of all the things of how they are changed. So this is interesting. I hope you like this video. As you can see, I'm just working through all this stuff. What are the plans for Python.cards? Well, I'm working on getting this site ready. So the site is kind of ready. It is deployed even and so on. But I want to release some videos. I want to add some cards. So here, let's count the cards that we did today. Where is this saved? I don't know. Let's go to Python.cards. Cards pathlib.md. This is empty. I'll find it later. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think we got about 40 cards. So we got 40 cards in about a couple of hours. So that's 20 cards per hour. So I'll be putting in some more hours still. I think this is a pretty good amount of cards for, I would say, a couple of days. So maybe you would learn between 10 and 20 cards per day, depending on your goals. So I'll add some more cards. The pathlib. Here I have some other ideas for decks or the nomenclature, which I kind of left for later because I think it's easier to cover one topic than go through all the possible topics in the nomenclature. I have a list here of lots and lots of words that you might want to learn for the nomenclature. So I have ideas for that. Then the built-ins are similar thing. So Python built-ins. Again, there's this list. It's a comprehensive list. It's not too long. We should go through each one of these and create cards for each one of these. And then I had other ideas. So this is the tour of the standard library. So this is similar standard library. So if we go to the standard library, we have this, all of these modules, and I want to go through all of them and not in depth. So like, it's not like we're going to get into, get pass and see what this does, but we can just a single card. If you want to input a password, what do? Well, you go to get pass, just so you know that this thing exists, right? So that will be for another day. This is enough for today. I hope you enjoy it. I hope you like it. Please go to Python.cards and join the waitlist. And see you next time. Bye-bye.